LeetCode No. Today's video I want to cover a problem and solution for a LeetCode problem. This LeetCode problem is an SQL database problem, which I'll be solving in MySQL. And the name of the problem is called Last Person to Fit in the Bus. So just to start off, I think what we'll do is we'll do select star from the input table that we're dealing with, just to see the data set we have to work with. So what we have to do here is, this is like a simulation of like a bus where people get on the bus. And so the first person to get on the bus is at turn 1. The person has an ID of 5, and the person's weight is 250. This input table is not put in order by turn here. It doesn't seem to be in any particular order, so you have to look through this. So on turn 1 we got this person, then on the second turn we get this person, Alex, at 350. And the idea is we have to consider that given these people enter the bus in sequence by turn, so turn 1, turn 2, turn 3, we have to find at which point do we hit a turn where the total weight, so let's say the weight of turn 1, 2, and 3, where the total weight is less than or equal to 1,000 kilograms. So in the example that they have here with this table, right, this person named John Cena, on turn 3, the weight is 1,000. So John Cena would be the last person able to board the bus, because at John Cena, the running total weight is 1,000 pounds, 400 plus 350 plus 250. And John Cena is at turn 3, so this would be the answer. The output is supposed to be the person's name here, right? So let's find the person associated with the last turn where the weight would be less than or equal to 1,000. So really you're looking for an output that only has one value in one column. So I'm going to bring here an Excalidraw where I think we want to paint a picture ideally of how we're going to arrive at the answer. I think what would be useful is, so let's say at turn 1 we have a person, right? Person 1. And then we have the total weight of that person, right? So let's say the weight is 10. And then we would want to know on turn 2, we really want to know the cumulative value. So let's say turn 2 is associated with person 2. And let's say if we added this turn 1 with turn 2, let's say we got a value of like 30. The point is we want to have a, let's erase this so it's not confusing. We want to have this so we're always aware of what the running total of weights, right? We need to know running total of weight, and that's it really. We just need to know the running total of weight, and of course we always need to know what the turns that we're at. So at some point we're going to be at maybe turn number 5. We might reach a turn of 7. We might reach some turn number. No matter what the turn number is, we're always going to know the running total, right? So the running total might be, let's say, 800. So it's not like we're going to break and stop as soon as we hit 1,000. We're just simply going to get the running total for every single turn. And then since this is SQL, we can always order by, right? We can order by And then we can also limit, right? We can also limit, which means only accept, which means limit is where we only accept 1 or 10 rows of data, right? So limit is where we only accept 1 or however many we want. So we can limit the resulting data set to just 1 row, or we can have, 5. We can limit it. So yeah, that's the idea here. That's the solution, where we're just going to keep track of all the turns and then get all the running totals. We're going to get all our running totals. Then we're going to order by our total, right? And meanwhile we're doing this, we're only concerned with if I think about this right, you're going to see it when the code comes out, but we're only going to be concerned where the totals are less than or equal to 1,000. So then we're going to be able to order by the total descending, so we can pick off the top, the highest number, and we can limit it to just one result, because our final answer has to be just one person's name, right? Our final answer has to look something like this. So I have the coding solution where what we're going to do is we're going to select person name, because we only need one column, from Q, U, E, U, E. We're going to alias this as Q, where, and remember we said we want to have this running total, right? So the next thing we do is have the running total. You can also call it an aggregate. We need to aggregate the total. Select sum weight from QE, where turn is less than or equal to Q.turn. Right? So we're going to keep getting this aggregate total where the turn is less than or equal to the turn we're on. So if we're on turn 2, we're only concerned with turn numbers that are less than or equal to 2. If we're at turn 5, we're only concerned with turn numbers that are less than or equal to 5. So we want to select where the sum weight is less than or equal to our limit, which is 1,000 kilograms. And then let's just show this. I wish this was a little faster. Okay. Right. So these are the people where if you were to sum their total weights, it's going to be less than or equal to 1,000, right? So if we just wanted this person, this last person, we have to limit and order it. Order by turn descending. Limit 1. Let's run this again. Right, so now we're at limiting it down to 1. And for the final answer, we don't need to include the weight. It's not required. That's the answer. So I will include in the video description a link to a GitHub where I have many other SQL solutions. If you want to see more videos like this, like and subscribe, and happy coding.